Hi everyone, how is everyone doing? Welcome to my third live stream here at Z Physics. How is everyone's day today? Do you mind just dropping a little message in the chat just so that I know that you can hear me and that you can see me? Apologies, I'm just a couple of minutes late because my tech wasn't working, like my iPad wasn't streaming to this, but I think I've got it. Can you guys hear me? Do you mind just putting a little message in the chat if anyone is here and can hear me well? Now, what I'm going to do is I'm just going to share my screen. Welcome, Nuclear Mathematics. Welcome, HRG43. Oh, thank you very much, Nuclear. Awesome stuff. How's everyone today? Hopefully you should be able to see my screen now as well. And yeah, pretty good, thank you. It's beneficial for Oxford International AS Physics. Yes, so this is going to be beneficial for all of AQA. By Oxford International, you mean the Oxford AQA. You're taking CIE. Yeah, absolutely. It will be beneficial. I'm pretty familiar with all the specs, so if something is not on your specific spec, I should be able to tell you. So tell you what, just while I grab a coffee, do you guys mind just stating your exam board and telling me what do you struggle the most with in A Level Physics? OCR A and mechanics. Okay, year 12. I'm just gonna grab my coffee. My coffee machine is right over there because I cannot function without coffee. Sort of. Okay, it's better. Okay, I'm back. Okay, what other exam boards do we have? We've got around 22 people in the chat. Let's have everyone join in and put a message in the chat. I want to make this as interactive and as useful for you as possible. Okay, we've got AQA. Thank you very much, Alan. I struggle in practical parts, specifically the suggested reason from uncertainties. Oh, okay. Yeah, so this here is very, very specific. Hi, OCR A, struggle most with understanding the question is asking and also capacitors. Yes. So I think understanding the question is all about two things. Number one, the command words, which we're going to do a little bit more. I know we did in the previous, and yeah, I think you were there as well, Marhaba. So the other thing is understanding the diagram. And if there's no diagram, we can quickly like draw a diagram. Take AS levels. Okay, yeah. AQA. I'm currently on a gap year retaking physics because I fumbled paper 1 and paper 2. Okay, hopefully all goes really well. Welcome back. Welcome to my channel. AQA struggle with mechanics quite a bit, but your videos have... Oh, thank you so much. I really appreciate that. Electromagnetism, yeah. So I'm going to do a little bit of electromagnetism. Is anyone doing iEdexcel by any chance? I think you guys have an exam tomorrow if you're doing iEdexcel in particular. Okay, now let's jump into the... Oh, you have the paper 1. OCR A. Okay, good. Yeah, welcome back. It's really good to see quite a lot of people are sort of regularly tuning into this. Now, the first thing that I wanted to do is to let you know how I focus on what to include in my sessions. So in terms of examiner's report, the examiner's report will be very, very useful. I've got a sample one over here. I think this one here is from OCR A, but you know, thousands of people take this exam board. It's something like 10,000 or something like just under that. So the general mistakes here will be applicable to all exam boards. I think OCR does really well by providing table each year in which they mention what do candidates do really well and what do they do less well. Edexcel does something similar. AQA does, rather than general skills, more like a breakdown question by question, but this is still incredibly useful. Simaha 2609 for waves. We're going to do some today. I also recommend having a look at my all of AQA waves video in which I go through everything on the portion with like every imaginable sort of type of question, etc. It took me like ages to film. I'm currently doing like an OCR version, and I'm deep into filming it. So hopefully it should come out next week. I'm hoping. But okay, now what did candidates do well on this paper? Now, they made their working calculations clear. So if you imagine that I have, let's say that, will this let me write? Yeah. Okay, so let's say that I had to, I don't know, let's do a really, really simple example. But let's say that I had to, I don't know, calculate the kinetic energy, and I just did this. Then I did like that. And then I finally did the final answer, I don't know, let's say 50 joules here. I know it seems almost funny, but especially when I used to mark things like mocks, etc., I would see this quite a lot, because psychologically, sometimes we want to avoid writing in the middle just in case we have to remove something. But this here is, is really important. Please don't do this. If you were to have to sort of structure your work, especially more complicated stuff, just write down E is equal to a half mv squared, I don't know, a half times, I'm just making up some numbers now, multiply this by 5 squared, and this here is going to give you the correct result. Okay, showing each step in show calculations carefully. So if the show question, we don't get any marks for the final answer. And this is really, really important. Made clear which instruments would be used in the investigation. So in describe and explain questions, literally every time that you're using an instrument, no matter how easy it is, if you were to say the word, I don't know, measure distance, always include measure the distance with a ruler if it's a distance above like 3 centimeters. Use micrometer screw gauge if it's below 3 centimeters or so, or use a vernier caliper, etc. Okay, let's have a look at some of the questions as well. Tensor calculus, that is the coolest name ever, by the way. I love tensor calculus. Have you actually done any sort of tensor work? This is really advanced. I'm doing GCSEs, AQA, but we're doing a lot of A-level stuff in my own time for fun. I mainly struggle with long answer questions. Yeah, I think if you're not doing A-levels, I would just focus on the actual calculations and just learning the physics. And then I would probably almost like temporarily don't worry too much about the written stuff, I would say, and just focus on, I would even have a look at things like the British Physics Olympiad Senior Challenge and round 1 questions, just to develop that amazing understanding of physics without actually having to worry too much about sort of describe and explain, etc. How would you suggest to approach question in physics when they present real life scenarios? I don't know where to start. So I would start off with the fundamentals, because ultimately every single thing that comes up in a question will be something that is a physical situation that you know something about. For instance, I don't know, there was a question from AQA that I solved recently when I was tutoring, which was, it had like, some of you guys might recognize this question, but there was like a ball which was being dropped, and there was a method of determining the distance that it drops by measuring the time period of something which moves like this. And if you think about it, this ball here falls off a certain distance, and we know that. Okay, well, we can probably time this, and during that time, it presents is going to strike the this pendulum thing essentially here, and is going to leave a mark. So whenever that happens, this gives us a measurable distance. So even though the situation looks incredibly confusing, if we were to go through it sort of step by step, this here is actually okay. And I think the main thing is to really try and visualize what's happening in the problem, because every single real life scenario involves something kind of like deep, which is actually quite simple in its fundamentals. When it's added together and it's been layered up and it's kind of like been hidden and wrapped up by an examiner, it can be tricky to get. Okay, so OCR A, fantastic. I'm going to try and answer all your questions. So, hi, sorry to interrupt. I want to ask if you clarify uncertainties a bit. As my last exam, sometimes the answer was half the resolution, half the range. So, Boire Flex, if you tell me what exam board you are, I can let you know. But in general, so half of the resolution is your absolute uncertainty. If you're given data, you want to use half the range, but only if you're given data. Now, many exam boards such as OCR often use this as the resolution due to rounding. So let's say if the resolution is half a centimeter, 0.5 up to one significant figure is 1. So this is where the confusion sometimes occurs, essentially. So hopefully that clarifies this. Okay, what I was trying to ask is, what would you recommend reading advanced physics books as year 12 to get a deeper understanding? Probably Feynman Lectures of Physics. I think this is really, really good. They're completely for free online. If you type in on Google Feynman Lectures on Physics, you're going to find them. They are a very deep book written by a physics genius, so I really recommend that. Okay, honestly, I've learned calculus-based physics helped me so much, like different. Yeah, completely agree. Calculus-based physics is amazing. Do I have any videos for? Yeah, I've got probably like over 500 videos on problem-solving physics. So if you just have a browse through my sort of channel, you can find absolutely loads on a lot of different levels. Anywhere from, I've got a GCSE channel all the way to A level, all the way to sort of higher level Olympiads. I even got like some high university level quantum mechanics, but not so many of those, but I do have some. Okay, now another thing. Now let's go back to this. So what are some other things that the examiner tell us that we did well on? So, okay, explain what they would do with the data taken in the investigation clearly. And this is something that we're going to be practicing in A level in particular. It could be in the form of a graph, right? So we should never, ever, ever write things such as, I will take some numbers and I'm going to plug them back into the equation, right? We always plot a graph. Okay. Use the data and relationship book wisely. This is really important. You're often given equations that might sort of help you they will sort of help you. Just knowing it inside out is really, really important. In a way, you want to be so good that you almost don't need it. Especially with all the problem solving, you will memorize all the constants, not because you're trying, but because you've used them so much. Work through multiple choice questions logically, having removed unlikely answers first. I think this is a good tactic. Yeah, if a question is taking too long, I would say probably move on. And also, you want to practice such that your A-level papers are not taking like the required time, which is around 2 hours. If you finish a little bit quicker, this is going to give you plenty of time to come back. Remembering definitions of important concepts. This here is really, really important. Calculator error, yeah, is something that can appear, and it's worth practicing. A couple of notes, actually. So perform calculator operations accurately. So typically it's things with brackets or missing squares. So if I include, let's say I have to include, I don't know, r squared. These days, the way I reduce my calculator errors, and everyone does calculator errors, by the way, is I just type in my brackets first like this, and then I put a square here. And I know it takes like an extra 1/10 of a second or something to do this, but if I do this every time, I'm never going to miss a square, right? And that's the thinking. In terms of what candidates did well, who did less well. So what are the most common mistakes? Showing your thinking in a disorganized way, mistakes with trigonometric functions, forgot ideas how about investigative work is performed, including the universal need for a relevant graph. Okay, forgot some aspect of GCSE physics, misread the question. This here is a really important part like this. Did not address all aspects of a level of response question. I'll show you this. This is kind of OCR specific. Reuse answers from previous mark schemes without thinking how to apply them. Yeah, so this here I've noticed a lot when I used to mark things like mocks is you kind of like see a question, and then you've memorized the math scheme, and you try and sort of put that through without actually thinking about how to sort of apply this. Okay, let me have a look at some of the questions to keep this interactive. I'll be watching this until my exams next year. Fantastic. Why is A Level Physics non-calculus based? Why it feels as hard due to having to cut it down so much? Why is A Level Physics non-calculus based? It's a good question. I would love it to be calculus based. I think there's a teacher retention crisis in the UK already, and I think it just literally might be hard to staff for schools if it was calculus based. Another reason is we want to keep it as open as possible, so you don't have to technically take A-level maths. Even if some schools require it, there are many people who go for things like medicine. Some of you guys might be applying for medicine, for instance, and take, let's say, all three sciences. So these are just some of the reasons. Okay. Do you have any summary videos on important definitions? Not actually on specific definitions. I've been a little bit hesitant to do them because sometimes they do tend to change a little bit from year to year. But maybe I'll make some before the actual papers. Come back to ASFC. Oh, I miss you guys at ASFC. How's everything going at ASFC? Yeah, I really recommend use mark schemes. Any tips for paper 1 tomorrow? I think read the question, make sure to go over any, I would say have a look at any mistakes that you've done in the previous past papers, and then sort of work on those. Where am I from? So I'm originally from Bulgaria. I'm currently right over here, actually. But I used to teach near Manchester for over 10 years, probably 11 years or something like this. And I'm back in the UK in a couple of weeks as well. What study technique would you recommend for remembering how to answer certain questions? Active recall. So I think for pure memory, every person is a little bit different. I do quite well with writing, so this works quite well for me. The other thing is potentially spaced repetition. Like, let's say I don't remember the definition of superposition. Mind you, the result, when two waves interact, the resultant displacement is equal to the sum of the individual displacements, right? Let's say I don't remember that. Then after a week, I might remember it again. And every time I revisit that, it becomes easier to actually reproduce this. And if I've done this 100 times or 50 times, let's say, to be more realistic, before the exams, I will have no problem that will still appear on the actual exam. Learn the most general way. The masking was the definition. Masking swing system. Can you go from a D to a B in a few days? And what would be the best method to do so? To go from a D to a B, what I would do is focus on, typically, if you're working at a D, there's something in the content which is actually missing. I would try to identify this and really, really focus on that. You might want to rework your style of working as well. I mean, I've not seen your work, so it's a little bit hard to comment on it, but make sure that you remember all the definitions of the examined material. That's you probably know quite a good you probably know quite a few of them because you're already scoring a D. So it's a question of finding that extra sort of around 20%. Most likely, your definitions are okay, I would say, but what you want to work on is your longer calculations. So take a paper, have a look at some of the longer, I would say, between 2 and 4 marks, and really focus on them. Because these are some of the things like multi-step calculations. These are some of the longer questions and describe and explain questions which are really, really going to help you. Z Physics, are you teaching at a school? So last year, I used to teach I was the head of physics at Ashton Sixth Form College, but now I do this full time. Okay, so let's go back to some actual problems. Now, Edexcel also gives this gives a few different sort of pieces of advice. It's a little bit less structured, but let's have a look. So this here is just some advice from Edexcel in particular. Candidates will prepare for topics on specifications been previously examined. Okay. Questions that involve calculations produce significantly better marks. And look at this. Than questions requiring discussions or explanations. And this is one of the things that's kind of like inspired this live stream in a way. So we're going to be focusing on those. And I mean, almost every year is the same. So let's have a look at another one. I don't know, this one here is from 2022. So let's see, number of cases. So in the show, quite okay. What does it say over here? Yeah, so some candidates did not seem to understand the language and process of quantifying uncertainties in practical work. There were instances where candidates disadvantaged themselves by not using suitable, precise language. So the written questions are always where a lot of people actually struggle on. So this is what we're going to be focusing on. So here's an Edexcel question. Let's just focus on just the first bit. This could be on any type of question. So we've got a cyclist, and then they produce a video there's a velocity against time graph over here. And what we need to do is to explain. Now, remember, explain is tell me why, right? That's it. Let's have a go. Explain the shape of this graph and include a consideration of a force as part of your answer. Tell you what, let me mark your work. So if you're in the chat, there's 26 people in the chat. Remember to smash the like button, please, and like and subscribe and all that YouTuber stuff. But okay, chat, have a go. Have a go. Excuse me. Gosh. Explain the shape of this graph. Have a go. Have a go. You guys can totally do this. I fully believe in you. Let's all join in. If you can hear my voice, there's around 30 people watching. I think if my statistics are correct. Let's put an answer in the chat. Gonna give you a minute or so. Gosh. If it's a 3 marker, you probably want to focus on that initial bit. You probably want to focus on that middle bit. Then you want to focus on that end bit over here. So why is the velocity increasing? That's what we need to explain, right? Why is there acceleration? And if the mass is constant, if we really think about it, there's only one reason for the velocity to be increasing. Okay, there is a driving force. Okay, and also a drag force. The velocity increases. Hence the gradient increase when the... Okay, so let's think about the gradient though. What is actually happening to the gradient? So is the gradient increasing? It's actually getting less and less steep, right? Terminal velocity occurs in constant velocity, so flat line. I'll just change the word flat line to a gradient of 0. Increasing gradient leading to increasing acceleration. But if you think about it, in this particular graph, think about this. So this here is a steep gradient. This here is a less steep gradient. This here is a gradient of 0. So the gradient is not increasing with time, I'm afraid. So how would we actually word this? Well, let's do this one together. Now, we want to explain. In other words, we don't need to describe. So a lot of you guys are describing this by telling me what the gradient is. But we don't want to describe it because the question is asking us to explain. Now, why is there an acceleration to begin with, right? Well, we can start with the fact that there is some initial acceleration due to a resultant force, right? Because this here, I'm going to call it the driving force, due to a resultant driving force. Like this. Now, the acceleration is decreasing because the gradient seems to be decreasing. We know that. Now, but what is the fundamental reason that the acceleration is decreasing? Well, the reason for that is because resistive forces increase, right? So things like air resistance is probably a little bit too negligible unless they're incredibly fast cyclists initially. Well, actually not that negligible, but there is also mechanical friction and all sorts of resistance. Now, okay, so there is decreasing acceleration due to increasing resistive forces. What I would also add is that the net force decreases. Net meaning resultant. I'm going to write over here. Now, third marking point, we definitely want to comment on this, and there is no acceleration at the end. As the resultant force is 0. So this here was a question where if this was a described question, we would have answered it completely differently. If we were to describe the shape of this graph, we would say that initially there is a high acceleration, which is shown by a high gradient, and then the gradient decreases with time, meaning that the acceleration is decreasing, leading up to a region of 0 gradient, i.e. 0 acceleration and a constant velocity. This is how we would describe it, but this was explain, which means, well, tell me why. Okay, I can't remember. I have a feeling this is from A2, but it's the same material. So if you're in the UK, if you're doing like the standard Edexcel, I mean, they're all examined in the same sort of portion. And technically, this could be anything. Like it could be the graph of, I don't know, a magnet and electromagnetism or something like this. So it's not something sort of super specific. Okay, cool. Right. So let's do another one. Okay, I wanted to show you something which is really, really interesting. But how many people here have done electromagnetism already? If not, please like bookmark this live stream because I'm gonna show you like a massive secret. It's not a secret, but a massive advantage for your exams. Not yet? Okay. Anyone here done electromagnetism? I'm gonna need a volunteer for this live stream. If not, I'm going to. Okay, cool. So, Priyam, would you like to be my volunteer? Oh, self-studied Maxwell's equations. Amazing. Okay, so Priyam, here's a question which I've actually hidden. And there's a question which it's got like a complicated diagram and this and that. Can you what is the only answer that could ever be on why is there no induced EMF? What do you reckon? I feel like I'm teaching a proper class. Amazing. What do you reckon, Prem? How would you answer this? No pressure. Okay. What is Faraday's law, Prem? Fantastic console. No, keep going. No change in. So there, exactly right. Yeah, that's okay. So Faraday's law says that there's an induced EMF if and only if there's a rate of change of magnetic flux linkage. We write this as like so, right? So it almost doesn't matter. They're going to try and sort of like scare you with these kind of complicated diagrams where like it's making you overthink. But in reality, if there is an induced EMF, they ask you, why is there an induced EMF? The answer is always, there's a rate of change of magnetic flux linkage, or there's a change of magnetic flux linkage. Yeah, exactly right, Edwards integrals. Now, in this case, and look at this. It's this complicated diagram. We might sort of have to use that later on the question, but it just literally says there is no change in magnetic flux linkage. Yeah, and this is going to be true for every single problem. Okay, are you guys ready for another trick? I just started physics after a year. I want to become a mathematician or physicist. Amazing. Yeah, excellent. Technically, yeah, it's one of the differential equations of one of the most beautiful set of equations known as Maxwell's equations. Maybe I should do a live stream on like further physics and we can have a look at like Maxwell's equations or something like this, or relativity. That would be quite cool. When do you schedule those live streams? That's a good question, to be honest. So I thought I was going to be quite busy this weekend. So yesterday I realized that I was not going to be so busy. So I scheduled it last night, basically. So you can join my live stream, and I always put the date on. But unfortunately, I cannot commit on sort of a given day because I travel quite a lot and so on and so forth. But I tend to do these regularly. And closer to exams, they're going to be happening a lot more. So now, really want to get into electromagnetism, but we just started waves part 2 in quantum physics. Yeah, that's really, really good. Thank you very much. Now, let's have, who here does AQA? AQA, let's put something in the chat if you're doing AQA. Awesome. This is actually true for all exam boards. Actually, it doesn't really matter which exam board, but let's get everyone here who does AQA involved a little bit more. Okay, now AQA, actually an OCR, and Edexcel, but I think Edexcel maybe, no, Edexcel use that a lot as well. They're going to give you something like this. They're going to give you a complicated looking diagram. I don't know, some sort of a laser passing through a diffraction grating with like a million things through it, something like this. And then they're going to ask you, explain how light from the diffraction grating forms the first maximum on the screen. Once again, it's an explain question. Tell me why. So for 4 marks, put that in the chat. And then I'm going to give you a structure to help you with this. It's really, really important. You guys totally got this. Have a go first. And then I'll give you potentially a structure on how to actually tackle these. And this will always, always be true. As a hint, I would say always comment on the 2 PDs, path difference and phase difference. Have you done superposition yet? That's really good, Oliver. Do you recommend any book for beginners? So are you currently studying physics in any way nuclear? Because the answer will depend on sort of on whether you're at school. At what level are you currently studying? 10th grade, okay. So I would probably start off with the physics textbook that your school is using. I would, if you wanted to develop, if you want to have a book which kind of has it all, Halliday Resnick is quite good. I used to study that when I did AP Physics a long time ago. Jung and Freeman, yeah, this was my university textbook. I love that book. I still kind of solve random problems from it every once in a while. Yeah, I think I'm actually planning to go over Jung's double slit experiment. This is very, very similar to it, actually. Light diffracts as password, yeah, really good. Causing waves to meet in phase and superpose. Really good console. Just one thing missing. I think MIT has a course in waves as well. I would probably focus on some of the A-level material first. How are you finding the A-level material in waves, Edwards integrals? I'm just about filming. I've started filming I'm kind of improving my OCR A videos. So I'm redoing the whole of waves, which is taking such a long time, but I'm hoping that it should be out this week. Yeah, exactly. And because it's the first maximum, we can actually say that we can actually, okay, so here's how to answer this. Number one, mention why the light spreads. Diffraction. Welcome to this live stream. It's for both. If you have, this here is currently AS content, but it's for both year 12 and year 13. Number two, mention superposition. Mark number three, comment on the path difference. And we can currently see, because it's the first maximum, it's going to be equal to 1 lambda. Then comment on the phase difference. In this case, not necessarily. So because the question is asking us to explain how it forms, right? Not necessarily the conditions for forming or so on and so forth, or to explain what monochromatic or coherent actually means. So that's an excellent question. So light is diffracted from the slits of the diffraction grating. The waves superpose on the screen, right? So if I have something like the double slit experiment, here are the two openings, and let's say that I have, let me just see, I'm just going to move this so I don't hide this. Let's see, how do I do this? I'm just going to draw this up here. So I have some laser. Let me get rid of this. I have a laser, and then let's say that it goes through this, through double slit like this, and then it reaches, it's going to form a pattern, right? So it's going to form something like this. The intensity is going to sort of like steadily drop a little bit. Now, the idea is, let's say we take a point over here. So what was the question? How do I link this to superposition? So the wave, which let's say passes through this slit, is going to travel this much, and this wave is going to travel this much. So the two waves are going to interact. Because it's a bright spot, they're actually going to meet peak to peak, right? And if we're going to look at a minimum, which is in the middle, I don't have sort of different shades of the red to kind of like draw it, but it's not going to be like kind of like on and off. It's going to be like continuous until it reaches a minimum right in the middle. I've always get confused between commenting on path phase difference. What's a good way to remember the purpose of each? So Robo, I would say comment on both. This here is a much better way to think about it. And I just think about this little graph, right? So I go, okay, this here is 1 lambda. And then I go, okay, this here is like 180 degrees. This here is like 360 degrees. And I know that each is going to correspond to the other, and then multiples of that as well. This here is going to be like 90 degrees, and we can convert those to radians, with 360 being 2 pi, etc. But in describe and explain questions, particularly in 4 markers, I always comment on both, just to ensure that isn't that just interference? What's the difference between superposition and interference? This is a really good question. So the interference pattern is formed by constructive and destructive interference. So typically exam boards look at the actual pattern which is formed. Superposition is just the interaction of two waves. So at each of those points, the two waves interfere and superpose. So I think we just use them almost interchangeably. But I think in A level, what they tend to look at is as a pattern. It's known as the interference pattern. And very often the mask scheme would say at point, I don't know, let's say if we call it P, the two waves interfere / also accept superpose. So they tend to accept both. But I would actually, I think AQA doesn't. If I remember some of the mask schemes, have a look through them. But I would just say the two waves superpose. Okay, right. So now, how many people have done or have started electric fields yet? If you're doing A levels, have you done electric fields? Even if you've not done it, this here is a really good example of how to tackle, describe and explain 6-mark questions. This here is an OCR question, but it's totally applicable to all exam boards. If you're doing AQA, this is going to be for paper 3. If you're doing any of the international boards, this is going to be for your practical paper. Now, don't leave the exam room. This question, actually, sometimes I was tempted to give this to some of my sort of first-year students when I was doing full-time teaching, because we can actually get a really, really good idea on how to solve this without actually knowing a lot of the equations. Yeah, trust me, they don't. Do you think knowing Gauss's law helps with understanding of some things in fields? Yeah, I think so. Like with anything that has a spherical symmetry actually helps. Even understanding what is meant by the gravitational potential of a sphere helps with that. Yeah, Gauss's law is fantastic. You can, for fun, you can try and derive it for gravity as well, because it also has the same spherical gravity, and you can do the surface integral of G over a sphere, and you get Gauss's law for gravitation, which can be useful in some applications. Okay, now tell you what, let's solve this one. This one is a little bit too long to ask you to comment, but I think, yeah, okay, so let's write it up. Now, the first thing that we want to do is read the question. Surprise, surprise. Okay, so we've got an arrangement that's used by a student to investigate the force experienced by a small length of charged gold foil placed in a uniform electric field. Okay, so the field is uniform, so that means that we can actually use E is equal to V over D. Right, perfect. This here is our electric field. The two vertical metal plates are connected to a high voltage supply. Okay, if there's some sort of a safety comment, let me just see if I can draw this. I would probably, I'm always starting to think that I'll probably make some comment on sort of using this carefully. The foil is given a positive charge by briefly touching it to the positive plate. Okay. The angle made with the vertical is given by the following expression, QE over W. I would also just change that almost immediately to tan of theta is equal to Q. Rather than E, I'm going to write V over D and W. Okay, now what is W? W is just the weight of the foil. Okay, so that's just mg, essentially. I'm going to leave it like that. Q, V, W over D. The angle can be determined by taking photographs with a camera of a mobile phone. Fantastic. They've even told us a measurement, right? So really, really good. You can also write that you can use a protractor for it, I suppose. Describe. Okay, so here's the important bit. What do they actually want us to do? Describe how the student can safely conduct an experiment to investigate the relationship between theta and E. Okay, so now this last sentence over here is actually telling me that what I can do is I can plot a graph of theta against E, or not quite. Anytime that I have angles, it's always worth plotting the trigonometric function. So I'm just going to make a note over here that I'm almost certain I'm going to be plotting a graph. Ooh, why do I keep writing theta? Sorry, I've been talking for too long. Plot tan of theta against E. And I kind of like bullet point this a little bit on the side. Identify any variables that must be controlled. Okay, well, I'm going to need to control almost everything here. I'm going to need to control Q, the amount of charge. I'm going to need to control the same, I'm going to be using the same force. I'm going to need to control W. And then I'm going to choose one of them. I'm either going to control the voltage and vary the distance, or I will just set the distance to be constant, and then I'm going to vary the voltage. And either one of those is going to be fine. Okay, now let's see. How are we going to proceed? Now, let's start off with a description. Okay, because that's the first thing that they want us to do. And I'm going to make my examiner's job a little bit easier. So I'm just going to say description. So, okay, the first thing that I probably want to do is, I'm going to say that I want to calculate the electric field. Why not? Actually, no, let's start off with the measurements. I'm going to measure V with a voltmeter. And notice how I'm always writing what I'm measuring each variable with. Okay, I'm going to measure D with a ruler. D was the distance, wasn't it, between the plates? Yeah. And I'll make sure to define this if that's the case, where this here is distance between the plates. Okay, so I've got that. I'm going to use those two variables to calculate because all I want to do is to investigate the relationship between theta and E. So let's say that we want to measure theta as well, with photographs with a mobile phone. Or a protractor, like that. Now, because the only thing I care about is whether tan theta is proportional to E, whether it's inverse proportional to E, etc. I'm not going to actually measure Q and W. I could. I'm not going to lose marks, but I'll probably waste a little bit of time. I'm going to also write something which is almost guaranteed to always increase my score, and that is to repeat each measurement multiple times. And find an average, or find the mean, or calculate the mean. So this here is my measured data. Very often questions need a calculated data as well. So what I'm going to do is I'm going to calculate the electric field using E is equal to V over D. Okay, now, so the one thing that is often really missing is, what are we going to vary, and then what are we going to keep constant? So in this case, I'm probably going to say, I'm going to write this maybe in red or blue, because this is really important. I'm going to say vary the voltage. Or potential difference V. and measure theta. Okay, now, so then in terms of the analysis, can you guys actually see this? Sorry. I'll have a look at the questions in a minute. Yeah, I can just about see this. In terms of the analysis, yeah, you can absolutely do this the other way. I opened YouTube to study physics and you're alive. Yeah, welcome. We can study physics together. So the topic of this question is electric fields. Now, in terms of the analysis, we're going to plot a graph. So who can tell me what sort of graph are we going to plot? Oh, I've written this down here, actually. But let's pretend I didn't write this. What sort of graph are we going to plot? Anyone? Let's write this in the chat. Let's get involved. Yep, we're going to plot tan theta against E. Fantastic. Plot a graph of tan theta against E. Ooh, how do I do this? I'm going to write this up here. And there's a really, really important sentence. I'm just going to write this up here so that you guys can see this. And that is, if the graph is a straight line through the origin, the relationship is correct. Anytime an OCR question in particular asks you this, it's true. I mean, AQA or Edexcel or Oxford AQA or any other exam board can ask you this, or CIE especially. But when you see to investigate the relationship, the way you investigate it is by plotting a graph. And then we have to say how we're going to analyze the graph. So then I would probably even say draw a line of best fit. If the graph is a straight line for the origin, apologies about my handwriting, the relationship is correct. Now, I've missed two things so far in my answer. What are the two things general things that I've missed out? Have a look at the list of things that they've asked us to do. Yeah, if you have an equation with a quantity it's a straight line. Yeah, I agree. Absolutely, Edwards integral. Yes, we need to comment on which variables are we going to control. And also we need to make a comment about safety. So if it says safely conduct, we need to make a comment about it. So, okay, so identify any variables to control. So normally I would write it down over here. Okay, I'm just going to say variables to control. So pretty much everything else in the equation. So we can say the charge, Q. We can control it. I'm kind of running out of space, but if I had a little bit more time in the exam, I'd write something like charge them with a constant current for the same amount of time, for instance. You could write something like this because it physically will work. The weight of the foil. For instance, the distance between the plates. Now, we also need to comment on how to do this safely. So in terms of the safety, we need to also make it specific to this. So things like, I don't know, wear safety goggles or store your chairs underneath the tables in the lab are a little bit too general. So if we wanted to do this, we could say we could set a maximum voltage within the safety limits. For instance, we could say that we should not be touching any part of the circuit while it is on. We can say, I think actually those two things are normally going to be totally enough. I found Olympiad questions a lot more fun, to be honest, as well. But these are just really, really necessary. And I mean, they can be really, really fun as well. Depends actually. So if it's a high voltage supply, typically it's within a range. So whenever I've used this, typically, let's say, I don't know, you can use things like between 1,000 and 5,000 volts. So we could say, okay, use less than the maximum amount of potential difference. But typically just adding a safety comment. So let's just say safety. I would say do not touch the circuit while it's on. It's possible that some of the materials might be quite hot, so I'll probably make a comment on that. There's one more thing, actually, which in terms of the description of the experiment, if I was to put some charge onto these, do you think it will stay there forever? What do you guys think? This is now part of the actual description. What's going to happen to the charge? Yeah, it's going to slowly leak out. So what we want to do is take measurements quickly. This is something that appears quite a lot even in quantum phenomena as well. Take measurements quickly to avoid charge leaking into the air. What happens is that electrons will leak into water particles in the air, particularly if it's humid. Okay, cool. So this question is actually not so bad if we really think about it. It's really intimidating when we see it, but if you just break it down bit by bit, you guys will be totally, totally fine. Okay. Does anyone have a Edexcel exam tomorrow by any chance? That's in the chat. Anyone? No, we're going to do something a little bit different. I wanted to go over a question with Lenz's law, but I think most of you guys haven't done Lenz's law, so we might just switch gear and do some. I was going to plan to end the live stream here, but do you guys want to do some multiple choice questions as well? Yeah. I think it's up almost instantly, and then afterwards it will. Afterwards, like the live chat takes a little bit of time to appear. Okay, cool. Right. So let's see if we can find some multiple choice questions to do. Oh, you got Unit 4 tomorrow. Okay, let's do this one as well. So we've got at least one person who's got Unit 4 tomorrow. Okay. We've got a simple electric motor consists of a coil that is free to rotate in a magnetic field. A student connects the motor to an ammeter and a battery. The graph shows how the current I in the coil varies with time. Explain when the current rises to a maximum and then decreases. And Edexcel is so nice because they're actually telling you to include a reference to Faraday's law and include a reference to Lenz's law. Do you have any advice on solving very out there questions from OCR that have been weird 6 marker, like the rocket one? Yeah, I mean, I didn't find the rocket one that weird, to be honest, because there's a few questions which really focus on just understanding of gravitational fields. And the more question you get exposed to from different exam boards, from Olympiad style questions, the more you recognize what situation they're trying to essentially describe in like a new way. And a lot of the new questions really focus on this. I think there was one question where if you come across like a suggest question, for instance, where you're going to see in the masking there's quite a lot. I think 2023 question was 16 or 17, where there was like a shoe which was being thrown from like a merry-go-round. That one was like a little bit weird. But if you wrote something correct about the physics, you would have been awarded marks. Okay, so let's have a go at this one over here from any Edexcel students. Okay, now, once again, let's focus on reading the question. It's asking us why the current rises to a maximum and then it decreases. Okay, now, what is the situation? This here is an electric motor, right? So in electric motor, what happens, well, how does an electric motor actually work? We want to produce motion. So initially, well, the switch is open. So I think that this here is going to be sort of like quite all right, because all I'm going to say is, by the way, if you're doing Edexcel for the 6 markers, I don't think you should use bullet points, just write in full sentences, because I think technically you still have like the quality of written communication marks, so just in case. But anyways, okay, so what am I going to say? Let's say we've got this region over here. So I'm going to say that initially, or should I just type this up? Can I add in, how do I add a text box onto this? I don't know. Never mind. Okay, so I'm just gonna write it up. So initially, the switch is closed. Oh, sorry, open. My bad. So there's no current. And that's just the first region over here. Now, I don't know whether that's going to appear in the mask scheme. Probably not, because it's asking us why the current rises. But just in case, I'm going to write this down, because I want to make it impossible to get marked down. I don't want to just answer the questions. I want to cover every single, and I want you guys to cover every single little aspect. So why the current rises to a maximum? So at the very moment the switch is actually closed, the initial current seems to be the highest. So the current is at maximum when the switch is closed. I mean, this here is just the initial current, right? So the current will be equal to the EMF and over the resistance R, which is the resistance in the circuit, including wires and everything. Now, something a little bit strange happens afterwards, because, okay, so due to F is equal to Bill, we suddenly have rotation, right? Because we have a current carrying wire in a conductor, and there's a net moment. But that's not what the question is asking. It's not asking us why it moves. If it was asking us why it moves, we would say that there is a current carrying wire in a magnetic field. So by F is equal to Bill, there's going to be a force couple on sides of the coil which are perpendicular to the magnetic field direction, which is going to create a net moment about this axis. In other words, we're going to have a rotation. So it's asking us why the current rises and then it decreases. So we've explained why it rises. Now, why does it actually decrease? So the reason why is that as the coil is rotating, we have a induced EMF, because suddenly we have a conductor which is cutting through magnetic field lines. So as the coil is rotating, an EMF is induced within the coil as there is a rate of change of flux linkage by Faraday's law. Okay, now what about Lenz's law? Well, the direction of the induced EMF is such as to oppose the change which caused it. Let's just write this down by Lenz's law. The induced EMF is such that to oppose the change which caused it. And I'm already feeling pretty good about my answer because I've covered a lot of important points, so I likely already have 4 or 5. Right, so, well, this effect here, I'm just going to carry on here just so you can see this clearly. Hence, the current reduces. If the current is reduced, now, why does this effect becomes bigger and bigger and bigger? Well, I would say it reduces. So let's just say that the faster the coil spins, the more the current is reduced. Okay, now this here was a classic sort of will you do any Cambridge AS streams? Maybe, yeah, possibly. Yeah, I'm planning to just do the most useful sort of AS and A level sort of streams. So closer to exams, I'm going to be just doing a lot of streams. You know, for the experiment where you determine the critical angle, you look at total return reflection using a ray box and a semicircular block. When you first shine the light into the semicircular block, I have some already aeronaut. Yeah, I agree. Is the faster causing high? Yeah, exactly right, Robo. So why does it not refract? Puzzle. This is typically because it's arriving in the semicircular path where it's, so if you have a semicircle, like this, the normal is the radius, right? So if I have a ray which enters like this, it's not going to deflect when it enters this, and it's going, this one here is going to leave like this. Now, depending what the critical angle is, but if I have a ray which enters, let's say, along the radial line here, it is not going to refract. So this is probably what you're asking me. I actually have a question like this coming up in a little bit. Yeah, I think I posted a few Edexcel physics paper walkthroughs, but I'll do my best to do a few more. Right, Stuart, let's do a bit of OCR, but these are just like general multiple choice questions, just to finish the live stream. Just like 20 questions to finish the live stream. Why not? I think I can just about do that. Let me just check the time. Okay, yeah, why not? Let's do this. Right, who's still here? Is everyone ready for some multiple choice questions? Hello, how are you? Well, luckily for you, optics is not, well, depends what you mean by optics, but refraction, etc., is on the OCR spec, but the actual optics with lenses and stuff like that is not. Okay, right, so let's start off with a really easy one. Which is an SI base unit? Is it the amp? Is it the coulomb? Is it the ohm? Is it the volt? I feel like I'm a talk show host. For $1 million, what is your... Yeah, correct answer is A, the amp. Okay, what about the next one? You're all winners. Two waves of wavelength lambda undergo constructive interference. What is a possible path difference between the two waves and why? For bonus points, tell me why as well. Yeah, amazing. I'm teaching a class of geniuses. Really, really good. Yeah, correct answer is D indeed. So in order for the condition is, let's just do a little bit of revision, but for constructive interference, PD is equal to n lambda, where n is an integer, so zero phase difference, zero path difference is going to work. N is equal to 0, 1, 2, 3, etc., etc., etc. Okay, right. What is the next one? A couple wire has electrical resistance R, number density of charge carriers N. A couple wire Q has areas of cross-sectional area equal to P, twice the length of P. Which role gives the correct values of resistance and number density? I think if you guys are doing AQA, you don't actually do the naive equation, so don't worry about the number density part if you're doing AQA. Yeah, it has to be a whole number. What do you guys think about the next one? Yep, let's use the resistivity equation. Yeah, this is an AS paper. Yeah, really, really good. So there's a few things in mind over here. The first thing is that we want to use R is equal to rho L over A. And then the other one is I is equal to NAV, the naive equation. Okay, so the area is basically the same, but the length is twice as much. So basically just this thing increases by 2, which is going to increase this by 2 as well. The number density is not going to change because it doesn't depend on the length of the conductor. If you take, it's defined as a number of charge carriers per unit volume. So we always divide by the volume. So, okay, so we're only going to take C to be the correct answer. We can see that L doesn't appear in this equation. Yeah, correct answer is C. 4, the light emitted by a laptop screen is polarized. Hang on, I think I've got a polarizing filter. I might disappoint you if I don't have one, but all right, give me a second. Let me just see if I actually have a polarizing filter. Might have left them in the lab. Sorry, folks. I think. Oh, actually, let me check. Just check this cupboard over here. I think I've got some. I was convinced that I brought some, but maybe I'm wrong. In the chat, while I'm looking for polarizing filters, let me know if you have used polarizing filters in school. I'm sure I brought some. Oh, yeah, there we go. Amazing. Excellent. Cool. I made a mess, but I've got some polarizing filters. Okay, cool. Right. So shall we test this? Okay, what is this? I think this is a polarizing filter. So let's see what happens if I put this on here. Now, let's see if something happens if I try and rotate it. Not so much because, well, actually, I can see a big difference on my screen. I wonder if it works on my iPad. Okay, right. So, oh, look at this, a diffraction grating. What do you guys think you will see if I put a diffraction grating on the screen? I've got a little diffraction grating over here as well. All the colors. And why is that? Let's see this. Whoa, look at this. Can you guys see a rainbow? You should be able to see a rainbow. This one here is OCR. But what you're seeing now is just hopefully all the different colors. Now, okay, now let's see if this is going to work. So I'm going to try and show you my screen in front of me. If the cable gets disconnected, you might see me cut off, but hang on. Can you guys see my screen? Okay, that's cool. Now, let's make it so that this here is at a max. Is this going to work? Maybe. Is it going to work? Oh, just about. So what if I did this? Oh, yeah, look at this. So I'm just going to bring this. This is really hard. It's not as polarized as I would have thought. It's polarized in this kind of like direction here. Hang on. Can you see the effect? So you should be able to see the effect more if I do that. The effect is a lot, not so much as I thought it would be. Should we try with a phone? Maybe. So what about with a phone? If I do this, hang on. Yeah, just about. Anyways, you can see it. Okay, cool. I'm just playing with the equipment now. Right, what is the correct answer? Question 4, tell me what the correct answer is. Right, chat. Okay, yep. It's always going to change from maximum to a minimum every 90 degrees. So yeah, correct answer should be B, because initially it was normal and then rotated by 90 degrees. It's actually a cos squared graph, so it kind of like does this. Okay, cool. Correct answer is B. Next one. Diagram shows a network of 4 resistors. Okay, I really enjoy resistors too, but let's solve this quickly. So these ones here are connected in series. Those ones here are connected in series, but together they're going to be connected in parallel. So I'm going to do 200 ohms, and then they are connected in parallel with, what is it, 400 ohms like this. So our total is going to be 1 over 200 plus or 1 over 400 raised to the power of -1, which is going to be equal to 3 over 400 raised to -1, which is equal to 400 over 3. I'm not even going to put this into the calculator because 400 over 3 is a little bit over 100 and less than 150. So the correct answer has got to be B. Fresnel integrals and differentiation. Okay, 6. Tell me what you think about this one. This one here is a very common mistake. What is the phase difference between the points on the wave? This is a stationary wave. And why is that? Aeronaut. That is correct, by the way. So with stationary waves, points on adjacent half wavelengths are always in antiphase. So in other words, if all of these points, let's say here, are going up, all of these here are going down together like that. So yeah, phase difference is pi. What would the answer be if I had, I don't know, what is the phase difference between X, I'm going to say another point P, I'm going to put point P over here. What do you guys think? What is the phase difference? Actually, no, I'm going to put it over here. What would the answer be? 2 pi. Yeah, in this case, for stationary waves, because the pattern repeats, actually we'll just say 0. But not 2.25 pi. So this is precisely what I wanted to talk about. All of these points are in phase, right? So every single one of those points here are in phase. These ones here are in antiphase. These ones here are in phase. So all of these points which I've drawn in black are going up together. All the points in blue are doing the opposite of what the other ones are doing. So for a stationary wave, the answer is always either in phase or in antiphase. Nope. So just so X and P are going to be in phase, and it doesn't matter where I place P. I could have placed it here. I could have placed it, I don't know, here. All of those points are going to have the same phase, because this is exactly how a stationary wave works. Maybe I should buy a Slinky or something to demonstrate how stationary waves actually work. Okay, next one. In a demonstration of the photoelectric effects, a classic question. The clean surface of a metal is radiated with photons of electromagnetic radiation. Electrons are released from the surface of the metal. The intensity is then increased. Which statement is then correct? The energy, so X and Y are out of phase. Yeah, that is correct. Wait, what is it for Y at that point? Did you mean on the previous question? Why is pi, which is 180 degrees, out of phase, which is in antiphase? Okay, so if you increase the intensity, that means that there are more photons per second. And if you're doing AQA in particular, if in described questions, AQA loves underlining this in the mass scheme per second. So I'm going to underline this. If there are more photons per second, that means there are more electrons emitted per second. They're all going to have exactly the same energy, though, or similar energy, depending how much their individual required energy was, but more energy emitted per second. So because of that, we can say the correct answer has got to be B. Okay, electromagnetic waves pass through a gap of 3 centimeters. Which of the following will undergo a significant amount of diffraction? Intensity proportional power therefore to energy. Yeah, but this is only for classical waves. And now we're talking about particles. So that's actually the conundrum of quantum mechanics. Yep, it's microwaves. Little tip, how do I remember this? Well, here's a microwave oven. It's got a window, right? So you can see, well, the window is more like this. But in the window, it's got like a little mesh. And then it's got like a start button and things like that. But that mesh is like a few centimeters, a few millimeters, and that is roughly half wavelength. So it's of the order of a few centimeters to a few millimeters. So yeah, microwaves is around 3 centimeters. Well, excuse me. What is X-rays in terms of, what is roughly the size of an X-ray? Let's do a bit of general revision. What is roughly, who can tell me, what is roughly the size of an X-ray? I'm going to give you a clue. It's about the size of an atom. Yep, 10 to the minus 10, precisely right. Okay, cool. Question 9. According to Newton's third law, which, by the way, is that when two objects interact, they exert equal and opposite forces on each other. It is not every action equals, basically don't use reaction and action in A Level Physics. According to Newton's third law, forces always occupy in pairs, which statement is not true. The forces are acting on the same body. Yep, this here is completely wrong. So I always think of this sort of in terms of a picture, but if I have, I don't know, A, an object, B, and let's say that they're trying to collide or something like that, this here will experience a force due to B, and this one here will experience a force due to A. And those two forces are going to be equal and opposite. Classic counterexample is if you have, I don't know, weight, let's say mg, and the normal reaction. These are not a Newtonian pair because they're acting on the same body and they're a different type of force. The normal reaction is fundamentally an electrostatic force, also connected with something known as Pauli's exclusion principle in quantum mechanics, but also mg is a gravitational force. Okay, next one. Particle X collides with a stationary particle Y, no external force act. We're already thinking about momentum, right? Which quantity is conserved in this collision? We need to conserve the total momentum, so it's going to be, yeah, correct answer is going to be C, momentum of X plus momentum of Y. These are not too bad. This is just some general revision to finish the live stream. Okay, 11, the diagram shows current entering and leaving a junction in an electric circuit. Which diagram should be correct? So remember, what we need to preserve now is Kirchhoff's first law, the sum of the currents entering a junction is equal to the sum of the currents exiting a junction. So which one is going to be the correct answer? Yeah, I think it's D, isn't it? Because this one is going in, this one is going in. Total amount of current going into the junction is 6. I'm just kind of like write the currents going into the junction. Some of the currents is equal to some of the currents coming out of the junction. So, 1 plus 5 is going to be equal to 2 plus 4. Okay, yeah, correct answer is going to be D. You can clearly see that none of the other ones are actually going to work. In Young's double slit experiment, light passes through 2 narrow slits and a pattern of light is observed on the screen. What property of light is not demonstrated by this experiment? Fantastic. Correct answer is B. We're flying through this paper. Okay, 13. Have a go. Have a go. 13, in Young's double slit experiment, electromagnetic radiation is incident on the double slit. The following results are obtained. Distance from the slits to the screen, 3.5 meters. The distance between the slits, okay, this here is in millimeters, so I'm just going to make sure to convert that. Oh, look at that. The distance between the central fringe and the sixth or the fringe is 9 millimeters. So I'm going to say that my fringe separation X is going to be, well, what is my fringe separation going to be? Yeah, exactly right. So if this here is a central max, 1, 2, 3, 4, 5, 6, you've got 1, 2, 3, 4, 5. You got 6 of them, right? So I just want to visualize. But yeah, the distance, basically this whole distance here is 9 millimeters. And what we want is, sorry, gosh, my handwriting seems to deteriorate with this live stream. That's okay. So this here is going to be 9 times 10 to the power of minus 3 over 6. Okay, right, so we can use the equation. If only somebody could tell me what the correct equation for lambda was. Let's do a bit of revision. What was the correct equation for lambda? AX over D, thank you very much. Okay, so then we're going to do 9 times 10, this is just x, 9 times 10 to the power of minus 3 over 6 multiplied by a, which is 1.5 times 10 to the negative 3, divided by the distance, which is 3.5, and we should get around 6.4 times 10 to the power of minus 7 meters. Correct answer is A. Right, chat. A stationary sound wave is created in air. The distance between 2 adjacent nodes is 0.7. Okay, so for this one here, I'm going to use the fact that the distance between adjacent nodes is equal to lambda over 2. This here is a node, this here is a node in a stationary wave. You can kind of think of this as one complete sort of wavelength. So if lambda over 2 is equal to 0.7, that means that lambda is going to be equal to 1.4. Well, I can work out my frequency pretty easily just by using f is equal to f lambda. V is equal to f lambda. F is going to be what? gosh, can't rearrange. How bad is that? V over lambda, which is going to be 340 divided by 1.4. Correct answer has got to be A. All the other ones are too big. We don't even need a calculator if you look at like all the other answers here. It is A, isn't it? I haven't like messed up on this one. Yeah, okay, yeah, good. I can see everyone is saying A. Okay. Yep, fantastic. I really like how you're including your working out, Edwards. 15, the spring has a force constant of 4,900 newtons per meter. Force is applied to a spring, causing it to compress by 0.5. What is the change in elastic potential energy? Okay, well, we can probably just use E is equal to a half kx squared. This is not too bad, actually. I can just go a half times 4,900, 0.5 squared, like that. And because it's being compressed, that means that it's going to increase because it has the potential to do work now, because it's kind of like a toy, you know, if you kind of like wind it and compress it, it has the ability to pop out. Why don't we use f is equal to, you mean f is equal to minus kx? We actually do in year 2. It's actually going to be increasing, right? So the correct answer is C, because we are compressing it. So if we're compressing it, we're increasing the potential energy. Because if you imagine something like, let's say that this here is the balance point, I don't know. And then what we do is we compress it a lot and we kind of hold this into position. If we hold this into position, then release it, this thing here is going to, you know, do this. Yeah, we're going to do this. We're going to have to do this in sort of second year when we talk about simple harmonic motion with acceleration being proportional to negative kx squared. Edwards integral, you're in year 13, right? Have you done SHM yet? Yeah, so let me just kind of like write this on the side. What we use in second year is this, because, so if you have an object, this is an aside, but SHM, I don't know, let's say that we have an object like that. There's going to be a restoring force which acts on it. So this here is purely horizontal. The only thing that's acting on it is this. So let's say that F net is equal to minus kx, like that. This here is equal to mass times acceleration, which is equal to minus kx, meaning that A is equal to minus k over m multiplied by x. But also you know that A is equal to minus omega squared times x. This here means that omega is equal to the square root of k over m. And this here is the natural angular frequency of an object. Sometimes you get a question where they might give you this situation, they might ask you to work out around the frequency of oscillation. And then you have to say that 2 pi f is equal to root km, meaning that f is equal to root of k over m over 2 pi, or the time period of the oscillation. And loads of people miss sort of questions like that unless you focus on these. Okay, right, so this here was just a fun little aside. No worries, my pleasure. Okay, which of the following shows the stress-strain characteristics of a brittle material, such as chocolate? I had I think I had a lecturer when I was at university who was doing research into the stress-strain characteristics of chocolate. He had a disclaimer, like he had to sign an NDA because he was working with a top chocolate company, and he was researching what's the least amount of chocolate you can put in chocolate so that it doesn't break in the actual trucks. And there was a lot of like really interesting applied mathematics to work this out. Yeah, unfortunately, I'll be more interested in working on how do you maximize the best taste, but never mind. Yeah, correct answer is A. Yeah, so, things like, I don't know, chocolate, carbon fiber, glass, etc. Okay, which of the following is a correct statement about the EMF of a cell? You guys are making me hungry. I've not had lunch. I don't know what I'm going to have for lunch yet. Now I'm thinking about this, not about the EMF of a cell. Okay, which of the following is a correct statement about the EMF of a cell? What do you guys think? It is equal to the energy transferred from chemical energy per volt. Nope. So voltage in general is equal to energy per unit charge. Is there anyone in the chat who I've taught in person last year, out of curiosity? There was somebody earlier. I had this written on the window of the physics classroom because this year is such an important equation. So voltage is energy per unit charge. So this here should be per unit charge. It's not otherwise equal to any sort of EMF of voltage, right? So actually the correct answer is D. So if there's no current, you can measure this, because then there's no internal resistance. So it's equal to the PD measured across the terminals of a cell when there's no current. You take a voltmeter, you plug it in the cell, that's your EMF. So another way of thinking about it is just for internal resistance, the EMF is equal to the terminal PD plus V lost. E is equal to V plus IR. If there's no current, we can get rid of this term. So E is equal to V when there's no current. I'm saying when no current. So, okay, so this here is a tricky one. Okay, correct answer is D. 18, we're doing really good. Just 3 more questions to go. The diagram shows a semicircular glass block with a refractive index of 1.5. The glass is surrounded by air. Okay, so this here is a tricky one. Anytime you see a refractive index in a question like that, the first thing that you want to do, trust me, is to work out the critical angle. So I'm going to say that sine of the critical angle is equal to 1 over n. Critical angle is going to be equal to inverse sine of 1 over n, which is equal to inverse sine of 1 over 1.5. What does that give us? Let's see. If you guys have the answer, can you put that in the chat? Because I'm totally slow with this calculator. Inverse sine of 1 over 1.5. 41 points, around 42 degrees. 41.8. Now, my angle of incidence is way bigger than my critical angle, right? So because of that, it has to be A. If the angle of incidence was exactly 41.8, it will go along the surface. The correct answer will be B. If it's smaller than that, it will be one of those. But yeah, total internal reflection does occur. Okay, right, next one. You guys are doing so well. Student makes measurements to determine the total energy transferred by a filament lamp. They record the measurements shown below. What is the percentage uncertainty in their calculated value of W? Okay, percentage uncertainty question. The first thing that you want to do is write down an equation. Now, energy is just equal to VIT, right? It's essentially power multiplied by time. Power is VI. Okay, so I don't actually need to calculate the energy. All I need to do is, because I'm multiplying uncertainties, all I need to do is I need to add the percentage uncertainties. And the way I do this is right over left times 100, right over left times 100, right over left times 100. So I'm going to go 0.2 over 12 plus 1 over 80 plus 0.01 over 60. I don't care about whether the units are sort of consistent, because the milliamps here, for instance, would have cancelled, because I'm going to get 10 to the minus 3 here, 10 to the minus 3 here. Final bit, multiply by 100. I would probably even just do that in the calculator without actually sort of worrying about this. What is that going to give us? Anyone? Let's put this in the chat. What is this going to give us? Oh, I've already got the correct answer. If I put this, it's around 2.9, isn't it? 2.9%. Correct answer should be C. Excellent. An object is last question. Well done, everyone. Is everyone ready for the last question? An object is completely immersed in water. Upthrust acts on the object. Here's a diagram. Okay, there's some sort of an upthrust. Which calculation will correctly give the magnitude of the upthrust? Well, Archimedes' principle says that the upthrust is equal to the weight of the fluid that's been displaced, and the weight of the fluid is equal to the mass of the water that's been displaced multiplied by g. There can be only one correct answer, and that is C, as we can see. Okay, yeah, well done, everyone. I'm very, very pleased. Thank you so much if you've stayed for the entire duration of the live stream. Can I say downwards is negative, right was positive for A level, even though they normally don't use that for G? Yeah, I mean, if it's a long calculation question, as long as you're consistent, there is typically some sort of value which is given. So if they say initially the speed is v is equal to 5 meters per second, and they've drawn it to be going this way, we take that to be positive. In time, look. But yeah, thank you so much, and I'm sure I'll do another one next week at some point. And yeah, thank you so much. What is the difference between EMF potential difference using electric fields? Well, the difference between EMF and potential difference, we don't have to use electric fields necessarily for it. We just have to think about the energy conversion. So EMF is energy transferred from chemical to electrical per unit charge. Potential difference is energy transferred from electrical to other forms per unit charge. Thank you so much. Enjoy the rest of your day. Have a good one, folks.